Hi mathematicians, in this video I'm going to walk you through some additional substitution practice problems, and I'm going to be referring to these notes, which hopefully you do have nearby. Let me know if you don't have them, and please feel free to pause the video, rewind, anything that you need to do to make sure that you are able to keep up, and please let me know if you have any questions. So remember, my very first step is that I need to figure out which variable I am going to use to do the substitution. And the way we figure that out is by determining which variable is isolated, which variable is all by itself on one side of the equal sign. And so out of this whole problem, it's x that is completely isolated because there's nothing over here on this side of the equal sign, and x is equal to negative 2y plus 5. So step one, I figured out which variable is all by itself. Step two, I figured out, okay, what is that variable equal to by looking at the other side of the equal sign. So remember step three. This is the part that can be kind of challenging for people. You are going to take the other equation and you're going to write it exactly the same. You're going to write a negative 8. You're going to write a minus 3y equals negative 1. The only thing that's going to be different is that instead of writing an x, I'm going to write that equation with the negative 2y plus 5. So I'm taking the x out of the equation and I'm replacing it with what x is equal to. So again, I'm going to rewrite everything the same. So the negative 8, I'm going to write. But instead of x, I'm going to write parentheses negative 2y plus 5. And again, I got that negative 2y plus 5 from up here because that is what x is equal to, according to the problem. The part that a lot of people get wrong when they do this step is that then they forget to write the rest of the equation. So I already wrote my negative 8 here. I replaced my x here. Don't forget that I still need to write negative 3y. And then the equals negative 1. So now that I have that equation substituted, so you can see everything is exactly the same, except I replaced that x. So the next thing I have to do is I need to get this stuff out of those parentheses so that then I can try to make this a little bit more simple. And that is where step 4 from the notes comes in. We're going to distribute the negative 8 to the negative 2y plus 5, and we're going to do that by multiplying. So negative 8 times negative 2 is a positive 16, and because it's negative 8 times negative 2y, I need to make sure that I put the y next to it. So that's going to be a positive 16y. Negative 8 times positive 5 is a negative 40. And because I can't combine the y and the 40 because they're not like terms, they don't both have a y, I had to put that subtraction in between them. So I have now taken that negative 8. The negative 8 isn't there anymore because we used it to multiply. And now we don't have anything in the parentheses. Don't forget now to bring the rest of the equation down. So I still need to bring down negative 3y equals negative 1. So there's a lot going on with this equation, right? And so we can do step 5 from our notes to make it a little bit more simple. And the way we can do that is by combining our like terms. So 16y and negative 3y both have a y. So I can do 16 minus 3 and get 13. And since it's 16y minus 3y, that's going to be 13y. So I've taken care of the 16y and the negative 3y by combining those like terms. So I still need to bring down my negative 40 and my equals negative 1, because I'm still dealing with this equation. And now we just have a regular old two-step equation where we need to isolate the y. So I'm going to cancel out a minus 40 by doing the inverse, which is a positive 40. You know how equations work. If I do it on one side, I have to do it on the other side. So those are canceled. I'm going to bring down my 13y, and then negative 1 plus 40. Oh, oops. It would help if I added the right number, wouldn't it? Sorry about that. I need to add a positive 40 to both sides. Don't know what I was doing there. Okay, so negative 1 plus 40 is 39. And then finally, to cancel out the 13, I'm going to divide both sides. So y is equal to 3. Now remember, we cannot graph a point, and that's what we're doing, right? We're trying to figure out if we were going to graph these two equations, where would they intersect? So we can't do that without an x-coordinate to go with that y-coordinate. So now we're going to go back to that equation that said x equals, I'm going to make myself kind of like a little extra space here. So why am I using this equation? Well, I'm using this equation because I need to know what my x-coordinate is worth, and this equation says x equals. So how am I going to use it? Well, I know that y is equal to 3, and I know that from the first steps that we did there to get that. So I'm going to rewrite this equation exactly the same. I'm going to write the x equals the negative 2 and the plus 5. The only thing that's going to change is I'm going to replace the y. And what am I going to replace the y with? You got it. I'm going to replace the y with a 3 because I found out in my previous steps that y is equal to 3. So I am going to write everything exactly the same. I'm going to put parentheses around that 3 because remember, when these are sitting next to each other, that means multiplication. And to multiply numbers here, I either need to put parentheses around the 3 or put the little multiplication dot. I pretty much always use parentheses because I just think it looks more organized. So now I'm going to do my math. Negative 2 times 3 is negative 6. Negative 6 plus 5 is negative 1. So that means my x-coordinate is negative 1. And then finally, for my solution, remember that you do your x-coordinate first and your y-coordinate second. I see this mistake a lot. I'm going to write this in red because it's wrong, where kids do this because they solved for y first, so they think that that's the number that should go first. But remember, when we're doing ordered pairs, the x needs to go first. So this is going to be negative 1, 3 for our solution. For problem number 2, again, I need to start by figuring out which equation am I going to use to do my substitution, and I need to find the variable that is completely isolated. Like problem number 1, my x is again the one that is all by itself on the right side of the equation. Doesn't matter that it's on this side of the equation, it's still by itself because nothing's over there. And x is equal to 3y plus 4. I think it'd be a great idea if you pause the video and try to substitute, but you do you. If you don't want to, I get it, but strong recommendation. All right, hopefully you've tried to do this your first step yourself first. So remember what we need to do. We're going to take the other equation up here, and we're going to write everything exactly the same. The negative, the plus 2y, the equals -3. We're going to write it all exactly the same, except instead of writing an x, I'm going to write a 3y plus 4. So let's see what that looks like. So I'm going to do the negative. Instead of the x, I'm going to write 3y plus 4. And I'm going to put that in parentheses. Then I need to make sure, okay, so I got my minus for my equation. I took care of what I substituted in for x. Now I can't forget the plus 2y is still part of the equation. And the equals -3. So now, in order to get all of this out of the parentheses, I need to distribute. But I don't see a number here in front of the parentheses. So remember, if you don't see a number there, it means that there is what's technically in front of there? A 1. And because there's a negative, this is actually a -1. So I'm now going to multiply. So -1 times +3 is a -3. And because I have the y, it's a -3y. Then I'm going to do -1 times 4. -1 times 4 is -4. Again, this one doesn't have a y, and this one does have a y, so I can't combine them, so I need to put that minus in between them. Then I need to bring everything else down from the equation, so the plus 2y is still part of the equation, and the equals -3. So now, like I did in my previous step, I'm going to make this equation a little easier to work with by combining my like terms. This one can be a little tricky for some people. Remember, use your calculator if you need to. -3 plus 2 is -1. So -3y plus 2y is a -1y. Now that I put those y's together, I still need to bring down the -4, hasn't been dealt with yet, and the equals -3. I now still need to isolate my variable, so I'm going to cancel out -4 by doing the inverse, which is +4, and I have to do that on both sides. So that is going to cancel. I'm going to bring down my -1y. -3 plus 4 is +1. And then finally, I'm not going to cancel out that -1 with a +1. I'm going to divide both sides by -1. So my y is equal to -1. Just like in the previous example, we can't graph a coordinate with just a y coordinate. We also need an x coordinate. So once again, I'm going to take my equation that is solved for x, and that is the one that I am going to use. So I'm just going to put my 3y plus 4 equals x, and I'm going to write everything exactly the same. I'm going to say 3. I'm going to say plus 4. I'm going to write down an equals x. But the only thing different is instead of writing the y, I'm going to write a -1. So I'm going to do 3 times -1 plus 4. Negative 3 times 1 is negative 3. Negative 3 plus 4 is 1. So my 1 is equal to x. And then remember, my solution is x comma y. So it's going to be a positive 1 and a negative 1. So if I were going to graph those two equations together, that is where they would intersect on the graph. Okay, for number 3, at this point, it would be so great if you would pause the video and try it yourself. Okay, but I'm going to go ahead and hopefully you've done that. So first, I noticed that the x is the one that is isolated, and x is equal to 7y minus 9. So I am going to take my other equation. I'm going to write a negative 2 plus 3y equals negative 37. But I'm going to replace the x with that 7y minus 9. So I'm going to write my negative 2. In parentheses, I'm going to write 7y minus 9. Then I'm going to bring everything else down. My plus 3y equals negative 37. Then I need to distribute. So I'm going to multiply. So negative 2 times positive 7 is negative 14. And I need to add on the y. Negative 2 times negative 9 is positive 18. Then I'm going to bring down the rest of the equation, the plus 3y and the equals negative 37. Next, to make this a little easier to work with, I'm going to combine my like terms. Negative 14 plus 3 is negative 11. And because those both have a y, it's negative 11y. Then I bring down my plus 18. And my equals negative 37. Then I need to isolate the y in order to solve. So to cancel plus 18, I'm going to do a minus 18 on both sides. That cancels. I'm going to bring down my negative 11y. Negative 37 combined with a negative 18 is negative 55. And then I need to divide both sides by negative 11 so that my y-coordinate is equal to 5. It doesn't always work out that way that the y cancels or comes first, guys. It just happens to be that way on several of these. So now that I've got my y, just like I did before, I need to get my x. So I'm going to use my equation that is solved for x. And again, I'm going to write everything exactly the same. 7 minus 9 equals x. But instead of writing a y, I'm going to write a 5. So 7 times 5. Sorry, my 5s are so ugly. Minus 9 equals x. So 35 minus 9 is 26. So my x is equal to 26. So my solution is going to be 26, 5. Okay, hopefully now that you've seen 3 kind of worked out a little bit more step by step, I'm going to go a little bit faster for these last ones, but if you need to, review the video or whatever, by all means, please do. But I'm going to go kind of quickly at this point. So my isolated variable is my x. My x is equal to 2y plus 4. So I'm going to take my other equation, my negative 4, and instead of writing an x, I'm going to write 2y plus 4. Then I'm going to bring down the rest of the equation. So then I'm going to distribute. So negative 4 times positive 2y is negative 8y. Negative 4 times negative 4 is negative 16. Then I'm going to bring down the rest of the equation. So plus 6y equals negative 10. Then I have like terms that I need to put together. Negative 8y plus 6y is negative 2y. Then I'm bringing down the minus 16 that I haven't done anything yet with. And the equals negative 10. I'm going to cancel the minus 16 with a plus 16. So that cancels. I'm left with negative 2y. And then over here, I've got 6. I'm going to divide both sides by negative 2. So my y-coordinate is a negative 3. So now that I've got that y-coordinate, I need to use my equation that is solved for x. So I need to use 2y plus 4 equals x. I'm going to write everything exactly the same, except I'm going to replace the y with a negative 3. So I'm going to kind of write it at the top because I realize I didn't really give myself enough room here. So 2 times negative 3 plus 4 is negative 2. So my x-coordinate is a negative 2. So my solution is a negative 2, comma, negative 3. Don't let number 5 get you, because this one's a little different, because the whole time x has been the one that's been isolated, but this time our isolated variable is a y, and y is equal to negative x minus 3. So that means I'm going to take my other equation. I'm going to write 9x this time because the y is the one I'm going to use to substitute. And instead of writing a plus y, I'm going to write plus negative x minus 3. And then I'm going to bring down the equals 21. Next, I need to get rid of the parentheses. There's technically a 1 in front of those parentheses, but if I just multiply everything times 1, that's just going to be itself. So after distributing the 1, I'm pretty much just going to still have what I started with. Then I'm going to bring down my 9x and my equals 21. And then I'm going to do my like terms. 9x minus 1x, because that's what that is 8x. Bring down my minus 3 equals 21. I'm going to get rid of that minus 3 with a plus 3. On both sides, that's going to cancel. 8x is equal to adding those together, which is 24. Divide both sides by 8. My x-coordinate is equal to 3. You guessed it, though. We still need to get a y-coordinate. So I'm going to use my y equation. So my negative x minus 3 equals y. And everything's going to be the same except instead of writing an x, I'm going to write a 3. So I'm going to say negative 3, because that negative just goes in front of the 3, minus 3 equals y. Negative 3 minus 3 is negative 6. So my solution is, again, x comma y. So it's going to be 3 and negative 6. Okay, last but not least, what's my isolated variable? My isolated variable is the y. What is y equal to? It is equal to negative 2x plus 1. So when I rewrite the other equation, negative 3x stays the same. Minus 2 stays the same. The only thing different is instead of writing a y, I'm going to write negative 2x plus 1. Then I am going to distribute. I'm going to ignore this guy for right now because he's not part of distributing. So negative 2 times negative 2 is a positive 4. And I need that x, so positive 4x. Negative 2 times positive 1 is a negative 2. Now that I dealt with the stuff in parentheses, I'm going to bring down my negative 3x. And I'm just going to like put a plus there in between those because this was a positive 4x. And I'm going to bring down the other half of the equation. What was I thinking? Oh my, what was I thinking? Why did I write a y there? Sorry about that, guys. That should be a 5. So now I'm going to bring down that I've got the right thing written now. Equals 5. Sorry about that, guys. So now I've got my like terms I can combine. Negative 3 plus 4x is positive 1x, although we really don't need that 1 there. Then I'm going to bring down the minus 2 equals 5. Add 2 to both sides. X is equal to 7. And finally, now that I have an x coordinate, I still need to get a y coordinate. So I'm going to say negative 2x plus 1 equals y, so that I can figure out what my y is equal to. But instead of writing an x in a second, I'm going to replace it with a 7. So negative 2 times 7 plus 1 equals y. That's a really ugly 7. Let me fix that. So negative 2 times 7 is negative 14. Negative 14 plus 1 is y, which means that y is equal to negative 13. So our solution is 7, comma, negative 13.